Plugging in constants for x and y then z. One way to look at it is try to find out where it crosses the planes. Each plane, the xz, the xy, and the yz is one of those cross sections you're aiming for. So you could let x and y, you could, for example, if x is 0, what do you end up with? 4y squared minus z squared is equal to? Equal to? 4. So you have, what kind of graph is that right there? Hyperbola, thank you.
Well, how do you define if it's hyperbola or other stuff? Like, is there a certain
difference of squares. Difference of squares. In the chart, you can look.
Which chart?
Page 836, I think, something like that. 8 something. There's a whole chart. It tells you what shapes each one represents.
But that's different from what that is. Well,
this cross section is a hyperbola, right? Yeah, it is. Yeah, it is. I think so.
I don't see any hyper.
4. So you could literally plot some more points if you wanted to, and if you recognize that this is a hyperbola, what does hyperbola look like? Goes out like this. Vase with a V, like this. Okay, so that's that cross section right there. What other cross section could we do? Let's set z equal to 0. If we set z equal to 0, we end up with negative x squared plus 4y squared is equal to what? Does that look mighty familiar?
No.
It should. It's the same exact curvature, just on a different plane. What plane are we on now? The xy plane. We're on this plane right here. This green plane right there. And what's it going to look like? Does it cross? What happens when y is 0? What happens when x is 0? Y equals 1 or negative 1, right? We're still at the same point. So it's the same thing, but it's going out like this on the plane. So does everybody see this now? Yeah. It's hard to draw, but I'm doing my best here. And I think I'm doing a decent job here. It's not bad. So this is a spun shape almost. Looks like it's a spun shape. Spun. Like it's a rotational solid. Looks like a rotational solid. What?
It's like the end of the bullet.
Yeah. Does this make sense, everybody? Yeah, there's different approach methods. Okay, what does z equal the square root of x squared plus y squared? What is that? It's a half circle, right? Which part of the half circle is it? It's not a circle, it's a half what? Yeah, what's the radius going to be? Z, yeah, exactly. What about x squared plus y squared equals 1? What is that? It's a circle on the what plane? You have to be very careful about this. This is x, z, and y. It's a circle on the xy plane, right? So let's go out. How far do we go out? 1, right? Let's say that's 1, and that's 1, and that's 1, and that's 1. So this is the circle. Is there a z in there? So actually, what is this? It's a cylinder. Like a classically defined cylinder. This thing goes, here it is. Why not? No, we're just graphing this right here. X squared plus, we're graphing that first. Okay, I'm just graphing that one. So we have that. This is just the surface right here, right? These aren't super concentric. I'm doing my best. Okay, and z is the square root of x squared plus y squared, and z is between 1 and 2. So what are we going to draw here? So if I say it was 1, what does this look like? 1 is equal to the square root of x squared plus y squared. What is that? What shape is it?
Half sphere.
A half sphere. 1 is equal to the square. Really? Is it?
Isn't it a circle? It's a circle. A circle with the radius.
Same thing of what we just did.
Oh, yeah.
Okay. Isn't it?
Yeah, it
is. Wait a minute. It's not quite the same thing. What didn't I put in there? Square root of x squared plus y squared.
But you could square both sides.
Oh! both sides and get 1 is equal to the x squared plus y squared. Hey, it is the same thing. So it's okay. So far we're okay. What happens if we plug in 2? We get 2 is equal to the square root of.
So 4 equals x squared plus y.
So 4 is equal to x squared plus y squared. So what is that going to be?
That's just a much.
It's a bigger circle.
Yeah, so it's a radius of, not too much bigger, it's a radius of
2.
2. So 2, you have to square root it. So maybe, you know, it's a cylinder with that being the, like, intersection. What do we think? Do we think that's right?
The z is equal to 2, so we have to raise it.
You have to what? What's it going to do?
It'll be the half sphere that gets bigger as it goes.
Z equals to 2.
Yes, that's what we
Z
did.
is between 1 and 2.
Z is between 1 and 2, right?
Yes, but
Not y.
the extreme value.
You just plugged in 2.
We just plugged in 2, correct. I just plugged in 2, so 2 is equal to that. So what is this if I graph that? What would that be?
Oh, it's that.
The blue thing. So, what are you graphing it on? It's going to be a huge cylinder.
Is it this cylinder is what I'm asking? Is it that cylinder?
Yeah.
So what's this shape gonna be like?
Are we sure?
Well, it looks like that. You take z out of it.
2.
This radius is 2, right? So this, it does connect like this. What shape did I just draw?
Wait,
So it's like a
zero.
Hold on. This is, yeah, it does go to 0, but we're going from 1 to 2, right? So if this is 2 right here, 1 is right here. Ah! Hold on. There it is. 1 is right there. What's the radius at 1?
1.
1. So it actually hits right here and here. So it's the one that's bounded by this, right? So actually, I'll try to do a different color here. So the bound is going to be, there's the top, right? There's a hole in the middle. You agree with that? Here's the bottom edge of it, and here's the side edges of it. So it's a cone that's had its top, in this case, bottom off, right? And it's got a cylinder drilled through the middle. Exactly. There it is.
So you could think of it like a little, if you flip it upside
We're going to convert it to rectangular coordinates.
There wouldn't be a way to know what it is. But
Well, there would be if I have a chart that I gave you that's in rectangular coordinates, right? It's 6 of those different types, and I'm saying you don't have to memorize that. Yeah, we could generate a chart in spherical and parabolic, in cylindrical coordinates. Some of them won't even come out very nicely. And am I going to have you memorize those? No. Let's convert back to rectangular and see if something pops out at us. There's some great substitutions we can make. Can someone give me one of the substitutions we could make? Sure, hand. Josh, which one?
Could we distribute the p squared? So
Let's not distribute anything yet. What substitution could we make?
Oh, we know that rho squared is x squared plus y squared plus z squared.
Yeah, we know that. So x squared plus y squared plus z squared. That's great. We have this sine squared cosine squared, right?
But we need rho for everything else.
We do need rho for everything else. So we really do want a rho in there, right? I never said we weren't going to do this wrong, but if we distribute it first, if we actually distribute this first, what is rho squared sine squared phi cosine squared theta? What is that equal
Is
to?
that x squared?
No.
Yes.
X squared.
Isn't it? Oh, I even circled it. I'm sorry. I got lost again. It is. Okay, and then you know that what's rho squared cosine squared phi?
Z squared.
Z squared, right? So now you have x squared plus z squared equals 4. And that's a cylinder on the
Y axis.
around
the
a-
axis.
Along the y-axis.
around the y-axis along
And on
Of
the
radius 2.
yeah of radius 2. Yeah, it depends on how you cut it. Yeah, did that go nicely for us?
Yeah.
That was cool. That makes, I mean, you see why we don't have to immediately recognize things like that? Yeah, absolutely. Okay, another one from 12.7, another one from 2 surfaces. What's the lower bound that we think? Z is equal to?
R squared.
Yeah. And what's the upper bound? Z is equal to? 2 minus R squared, right? So again, what system, coordinate system are we in? Cylindrical, right? Something like that. What's a cylindrical coordinate? Cylindrical. Yeah, there we go. What is it? What's the first variable called? X row? Theta.
Because R theta.
Z.
R theta and
Z.
R theta Z. Oh, so what do you notice isn't a part of this?
Theta.
There's no theta. No theta. What that means is inside, this is really important, when we draw our axes, theta is the angle measure from the x-axis, looking down, going counterclockwise. Here's x, here's z, and here's y. Meaning whenever, does it matter what theta is? No. So what it means is if we go out to like any theta, so here's 0, right? If we go all the way around like this, if we go all the way around the theta, it doesn't matter how we change it. R and Z will be the same. Z is the height, and R is the radius. The radius on, it's down here, right? So there's R, and here's Z, right? So if we found one point, what happens when we rotate it? It stays the same, right? So there might be some, it might go wavy all on us, right? But this is a rotational solid. We've just defined it all the way around which axis?
Y-axis.
The z-axis. It goes around the z-axis. Theta revolves around the z-axis in this coordinate system. So let's look at the relationship here. Let's look at the easy one. Z equals what? R squared, meaning as R goes out, what happens to the height? It goes up. So let's look at one of the planes, for example. Let's look at the x, so let's look at the zy plane right here. So the zy plane. So x is coming out of this. As r gets bigger, here's r on this graph. R is the y-axis, right? R would extend on the y-axis. What happens to the height? Every time you go over 1, it goes 1, 1, 1, right? 2, 4, 3, 9, right? So what is this graph going to look like? What kind of curve? It's going to look like a parabola, right? And then, because it doesn't matter what the theta value is, what do you do with this parabola? Spin it around. So this parabola right here, yes, well, you could use washers to integrate this, sure. And then, so that's this one, right? And so we just graphed that one. What happens if it's 2 minus r squared? What happens if r is 0? It's 2. So let's say 2 high is up here. Here's 2. Is this parabola facing up or down? Down. This sucker just goes down. It's just like a football, exactly.
These stripes only have round tops.
Yeah, it doesn't really matter. That's why it's a simile. It's like. So yeah, it's like a football. Cool?